All right, these notes are going to be on graphing rational functions. So first we have the parent graph y equals 1 over x, and we're going to go back to making our tables. So I'm going to plug in -2, -1, 0, 1, and 2. So if I have y equals 1 over x, and I plug in -2, then I get -1/2. If I plug in -1, I get 1 divided by -1, which is -1. If I plug in 0, I get undefined. My calculator would give me an error message for that. 1 divided by 1 is 1. 1 divided by 2 is 1/2. So left 2 down 1/2, left 1 down 1, right 1 up 1, right 2 up 1/2. And there's a little bit of symmetry here, and so I'm going to go ahead and put a point there. So right 1/2 up 2, left 1/2 down 2. And what these graphs actually look like is almost like the corner of a table if the corner was like perfectly rounded. And these graphs don't really have a vertex, but they do have two asymptotes that cross. And so what we end up having is this part right here. Whatever would make 0 underneath the fraction, that ends up being a vertical asymptote. Right, and an asymptote, I'm not sure if you guys have heard of it before, but we're going to go ahead and write the definition at the top of your notes. An asymptote is an imaginary line, so that's why I drew it in dotted, because it's not a result of the equation, like the equation doesn't give us points to plot. So this is an imaginary line that the curve gets closer and closer to. So as you can see, the curve right up here it's approaching that asymptote. It's getting closer to it. Down here you can see the curve is approaching that asymptote, all right? Now you might also be able to look and see that there's an asymptote that works horizontally as well. And you can see the curve is approaching it from this side and the curve is approaching it from that side. Okay, so here is one rational function. Another is we could have 1 over x squared, which is going to change the way it looks a little bit. So if we have a table again, x and y, and we'll plug in -2, -1, 0, 1, and 2. If I have y equals 1 over x squared, 1 divided by -2 times itself would be 1/4. 1 divided by -1 times itself is 1. 0 squared is going to give you an error message, so that's going to be undefined. 1 divided by 1 squared is 1. 1 divided by 2 squared is going to be 1/4. So left 2 up 1/4, left 1 up 1, undefined, up 1, right 2 up 1/4. And so we're going to see that same vertical asymptote, and we're going to see those still kind of like a corner, but they do grow a little differently on this one. And what the x squared does is it makes the two curves show up on the same side of the x-axis. So again, we have this vertical asymptote here, and that's a result of this, because that x value can't be used. And then we actually still have the horizontal asymptote at 0. So instead of finding a vertex for these, we're going to say what the vertical asymptote and horizontal asymptotes are. And those are kind of what give us like our locator, basically. And then we have horizontal asymptote, y equals 0. Okay, So let's go ahead and try an example of this. So if we were to look to see what like the inside of the function is, we would say the bottom of the fraction is considered to be the inside of the function. And so when you list out what your transformations are, you would say that since this is the inside of the function, that plus 5 means that the graph has shifted to the left 5. And then the number on the end, the negative 3 on the end, tells you that you've gone down 3. Right, so if I start off with my points, -2, -1/2, -1, -1, a vertical asymptote at x equals 0, 1, 1, and then 2, 1/2. If we go ahead and shift all of those points to the left 5, then we're going to get -7, -6, 1 minus 5, -4, -3. And then if we have a vertical asymptote at 0 and we shift it to the left 5, that vertical asymptote is going to be at x equals -5. Okay, and then we're going to shift down 3. So this is going to be -3.5, -4, -2, -2.5. Also, it was an accident for me too. I picked numbers and my graph isn't big enough, so I'm sorry about that. Okay, so I'm going to go ahead and graph that vertical asymptote at -5, which tells you how far off the graph this is going to be. Okay, so -7, -3.5, -6, -4, and then we have -4, -2, and -3, -2.5. And if you can see it, your horizontal asymptote is actually going to be right in here. So if we want to see where in the equation you can find the vertical asymptote and the horizontal asymptote, because we know that for these graphs, the vertical asymptote and the horizontal asymptote are kind of like the locator point, which means we should be able to find them from the equation. So the horizontal asymptote comes from the number on the end. The vertical asymptote comes from the opposite of the number on the inside. And so the way that we find the vertical asymptote and the horizontal asymptote is almost exactly the same as a locator point, where we say the x value, I guess I should have put these backwards, the x value is the opposite of the inside, and the y value is exactly the same as what's on the end. So if you guys remember finding the vertex or the locator point in the other units, that's exactly what we did. All right, so domain and range are kind of interesting on these. So if we look at the domain, then we can see that we have all these x values over here, but we do not have an x value of -5. And then we have all the x values over here. So the way that we write the domain is we say we have from -infinity to -5, and then -5 to infinity. The way that we write the range is we say that we have all the numbers underneath -3 and we have all the numbers above -3, but we don't have -3 exactly. And so I would say -infinity up to -3, -3 to infinity. I guess I should have just written that smaller. All right, now these graphs should always have an x-intercept and a y-intercept unless an asymptote ends up being the axis. So I'm going to go ahead and graph this on my calculator. So you can type it in with fractions. So you can do 1 over x plus 5. with a -3 on the end, or you can type 1 divided by, and then in parentheses, put x plus 5, like that. So either way you type it, sorry, here you go. Either way you type it is totally fine. All right, so I can see my x-intercept is right there. I'm going to go ahead and do second trace, option number 2. So there's my left bound, there's my right bound. So x-intercept is negative 4.667. Plug in 0 to find the y-intercept. Now, if you don't like fractions, so if you type it in the way that I did the first one, it's always going to give you a fraction as an answer, if it can. If you type it in the second way, then it won't give you a decimal as the answer. So if I clear this, and then I do this problem again, and ask it to plug in 0, then it gives me that answer as a decimal instead. So whatever way you like to receive your answers, you can be careful with how you plug these in. I will have both answers for you on a test. So on a test, it doesn't really matter. These graphs don't have maxes or mins. So it's kind of like you're walking into a valley, but you never walk out of it. And so it doesn't go down and come up, which means it's not a minimum. This one is like you're walking down off a mountain, but you never went up and over it. So there's no max or min. So I will ask you if there's one, but you're just always going to say no. For increasing and decreasing, I like to go ahead and like sketch the picture again. So we have something like this. And this. So if I put a stick figure right here, this is my negative infinity. He's walking, he's decreasing, going down, going down, going down, and then he like drops off into the abyss. And remember, I'm not looking at this arrow because this is an x value and the arrow is like down. And this arrow is not going right forever because it actually stops at the asymptote. So the x value right here is actually -5. And then I start here at -5 and I pick up a new stick figure. And then this stick figure is like walking down still. And right arrow means infinity. So for increasing, we're going to say none. And for decreasing, we're going to say negative infinity to -5 and -5 to infinity. Is the graph continuous? So can you trace it with your finger? I trace this one and then I have to pick my finger up to trace the other one. And so we're going to say no. These are never continuous. Never ever. You always have to pick up your finger to trace the two different pieces. All right, so end behavior, we're going to look as x goes to the left forever. We're going to look as x goes to the right forever. And these are probably some of the more interesting graphs that we've done because they actually go to a number. So if you look as x goes to the left forever, there is an arrow, but it's never going to cross that y value. It's just going to get closer and closer to it. And as we look to the right, I can see an arrow, but the arrow doesn't go down forever. It's going to get really close to that asymptote. So as we look to the left forever, the y value is going to go to -3. As we look to the right forever, the y value is going to go to -3. So when we do the end behavior for these, we're going to notice that the y coordinate is always going to approach that asymptote. All right, let's go ahead and do another one. So if we look at this one to find the transformations, here's the inside of the graph. And so we're going to say that this goes left 1 and up 1. And so that means that whatever numbers are left over have to do with the stretch and with the compression. So if we were to put a coefficient in front of these parentheses, it would be a 1. And since this fraction is 3/1, we're going to say that that's a stretch. If there had been like a 4 down here, we would say that's a compression. 3/4 would be a compression. So to find stretches or compressions, you're going to kind of look at the top and the bottom. So here we're going to say vertical stretch of 3, and it's been reflected over the x-axis. Okay, so if we go ahead and we take our points so that we can graph this, then the first thing we're going to do is the reflect over x in the vertical stretch of 3, because we always have to do our multiplying first. And all of that stuff is going to happen to the y coordinate. So negative 1/2 multiplied by negative 3 would be 3/2. Negative 1/2, sorry, negative 1 multiplied by negative 3 is 3. Asymptote would not be affected. Multiply 1 by negative 3. Multiply 1/2 by negative 3. And then we're going to go left 1, left 1, left 1, left 1. If the vertical asymptote was at 0 and you shifted it to the left 1, it would move, so x equals negative 1. And then we're going to go up 1, up 1, up 1, up 1. Okay, so we have left 3 up 2.5. That's what 5/2 is, 2.5. Left 2 up 4. 0, negative 2. 1, negative 1/2. And I can go ahead and draw in the asymptotes. I found one of them in the table, but I could have found it from the graph. And then this one. So y equals 1, x equals negative 1. The domain is negative infinity to negative 1, negative 1 to infinity, because it skips that x value of negative 1. The range is going to be negative 1 to positive 1, and positive 1 to infinity, because you skipped that y value of 1. If we think about increasing and decreasing, we have a stick figure right here who has started at negative infinity and is walking uphill, so that's increasing. And then this is an x value of negative 1, and then he gets sucked up into a UFO. And so then we have a new stick figure who starts down here at negative 1, and he's walking up to infinity. So we're going to say our increasing is from negative infinity to negative 1. Negative 1 to infinity, and decreasing is none. This graph is not continuous, because if you trace it with your finger, you definitely do have to pick up your finger. To get the x-intercept and y-intercept, we do have to graph this. And so I'll go ahead and do negative 3 divided by x plus 1 with a plus 1 on the end. Again, you can type it as a fraction if you don't mind getting fraction answers for your intercepts. So my x-intercept is 2. My y-intercept is negative 2. There is no max or min. And then for the end behavior, we're going to say we're looking as x goes left forever, as x goes right forever. So as you look at the left side, you're seeing a y value of 1. If you look at the right side, you're seeing a y value of 1. And then don't worry about doing the last example. We will do that one in class tomorrow.